Good morning, everyone. I'm running a little bit late today, but we'll get going pretty quickly. Okay, today we're going to be starting to interpret the graphs of these functionally. We've done a little bit of this already. Okay. If you remember, this notation means that we're going to replace the x value with -3. This means we're going to replace the x value with 0. Well, what we're doing here is if x is 3, what is y? 1, 2, 3. So x would be approximately 2.5, 2.4, something like that. Okay. Not sure. Oh, got a pop-up. Sorry about that. Now we'll try it. Oh, you know what? I got careless. That doesn't say x is 3. It says x is -3. 1, 2, 3. And the y value is -3. Okay, if x is 0, maybe I'll get this one right. Looks like about 2.1. They just called it 2. Okay, now this notation means that y is equal to -1. And they want you to find x. So this problem is just backwards from the previous one. Okay, so if y is -1, right here, y is -1. So x is also -1. Okay, the next one, at 1, let's see. Oh, at y equals 1, duh, what am I talking about? Right here, we can't count this one because it's unincluded, but that point right there. So x would be 2, or y is 1, because this statement says y is equal to 1. Okay, determine the x-intercept. Well, in this case, there is no x-intercept because nowhere does it cross the line. the y-intercept right here at y equals 2, or the point 0, 2. Now, I need to make a point about something. If it asks you what is the y-intercept, it's expecting you to give the answer in point form, and it'll be a point deduct if you don't, if you just wrote simply 2. Okay, to determine the domain of f, what is the range of x values? Okay, and determine the range of f. Remember, the range is the set of y values. Well, this continues forever, that continues forever, and this point is included, so infinity to infinity. For the range, this goes to negative infinity, so that's our low end. We have a gap here, okay, that we're going to have to show with a union. Although this point is included, we're still missing from here to here. So we have from negative infinity up to -1, y is -1, and then union +1 inclusive to infinity. Okay. Find all x values for which the answer of y is 3. So if y is 3, okay, what do we have? Well, the answer is empty set. All x's for which y is 1. Okay, if y is 1, we have the set containing -1, -2, and -3. Or in interval notation, from 1 to 3, or -3 to -1. The x-intercepts, the x-intercept is 0, 0. The y-intercept is also the point 0, 0. The domain is negative infinity to 4 non-inclusive, a parentheses. The range is 1, 2, 3, 4, -4 non-inclusive to infinity. Okay, linear equations in 2 variables, okay? This is standard form for the equation of a line. A and B are just some numbers, and so is C. A and B can't both be 0. One of them can, but not both of them. Okay, here's an example. We're supposed to graph this. Well, in this case, we can graph this by using an XY table. Pick some values. I always like to choose those as 2 values to try to use. Here, let's try 1, 2, and -2, just for arbitrarily picking some numbers. Okay, here, if x is 0, then I've got -2, y equals 6, y equals -3. And I graph that point, okay? 0, -3. 0, -1, 2, 3. Okay, then the next point I've chosen, I'm going to let y be 0 and solve for x. So here I have 3x equals 6, x equals 2. So I get the point 2, 0, which is right there. Now, just based on those 2 points, I could draw the line, but let's go ahead and do another 1 or 2 of these. Okay, if I let x equal 1, then I've got 3 minus 2y equals 6. Subtract 3, subtract 3. Negative 2y equals 3. Y equals negative 3 over 2, or negative 1 1/2. That gives me the point 1, negative 1 1/2. So if I graph that, x is 1, y is negative 1 1/2. And as you see, that's lining up. Let's go ahead and use a negative value here. If x is negative 2, well, actually, it's going to go way down. It might hit right there. We'll go ahead and do it. So 3 times negative 2 minus 2y equals 6. Negative 6 minus 2y equals 6. Add 6. Negative 2y equals 12. And y equals negative 6. So that gives me the point negative 2, negative 6. And I didn't write down this last one, negative 1 1/2. Okay, so negative 2, x is negative 2, y is negative 6, actually down here. And we can draw our line through this. We could pick some points up here as well. Okay, here's the work on it. What they're doing here is they're finding the x and the y intercepts, which I did here. Okay. Let me erase some of my scribbles. Okay. You see, they basically found the x and the y intercepts, just like I did here. And they graphed those, that's these 2 points, the y-intercept and the x-intercept, and they just drew their line without a third point to check. And I want you to always use a third point just to make sure your line is correct and one of these two isn't in error. Okay, this time we've got a very simple equation. We're missing the y value. I want you to look at what happens. 5x equals negative 10. We simplify that, okay, and we get, divide both sides by 5, and we get x equals negative 2. What that means, and they're going to graph it for me, so I might as well let them. There is no y-intercept. Okay, well, actually, there's a y-intercept. There's no x-intercept because here's what you've got. What this is saying, what this equation is saying, is that x will be negative 2 no matter what. It'll always be that. So if the y is missing, that means it doesn't cross the y-axis. And it's a vertical line. Likewise, if we had an equation where the x is missing, then it would be a horizontal line. And unless the equation is x equals 0, it would never touch the x-axis. Okay, here's an example of that. Y equals 2, the x is missing. That means it's not going to touch the x-axis. So there is no x-intercept, but in this case, we get the horizontal line why everything is at 2. Slope. Slope is very simply what angle in space the line goes through. Now, we have various points like this. Slope, by definition, is the amount of rise over the amount of run. What that means is the change in y values over the change in x values. Or in other words, you're going to subtract the 2 x values, subtract the 2 y values, and see what you get, and then divide them. So let's go on. Here is the formula. By the way, this Greek symbol delta means change. That's a universal symbol in mathematics. The change in the y values over the change in the x values is subtracting one y value from the other and subtracting one x value from the other in the same order. Whereas these just represent 0.1 and 0.2, the subscripts do. Now, I tried to advance my slide with a marker. Okay, look at this problem. Let's find the slope of the line that goes through these 2 points. In other words, we've got a line over here. And on that line, we've got the points -2, +3, about here. And we've got the point 1, -8, about here. So here's my line. Now, what is the slope or the angle of that line in space? Now, I'll tell you right now, this line is going to have a negative slope because left to right, it goes negatively or downwards. If the line went like this, then it would have a positive slope. There's an old story that said, let me write an English sentence, and I'm doing it on a sheet of paper with nothing here. I hate math. Some of you may be blotted out on the word math. Now, supposedly, by analyzing my handwriting, you can tell whether I'm telling the truth or not, whether I actually hate math or whether I like math. As I write this sentence, I'm going uphill, left to right, the way we read things. And that would indicate a positive thing. Whereas had I written downhill, that would indicate negative, and yeah, I probably really do. Well, that translates to this. If the line goes downwards, left to right, it's negative. If it goes upwards, left to right, it'll be a positive slope. So, we're just calling these 0.1 and 0.2. So I take the y value of 0.2 minus the y value of 0.1 over the x value of 0.2 minus a negative, the x value of 0.1. Okay, I simplify this. I get -11 over 3. Okay, so that is the slope, or in other words, for every change in x value, Okay, this thing -11/3 translates to 3 goes into 11 3 times and 1/3, or 2/3 rather. That means that for every move in the X position, that this goes down 3 2/3 spaces, like that. Okay, here's another one. Only real difference is this one uses decimals in it. Hi, Claudia, I'm in class. I'll call you back. Okay, so basically I combine these, and I get that value over there. I can get rid of the decimals, move it one place here, move it one place there, and simplify this to -17/4. What that means, since this is negative, it's going to go downwards left to right, and it's going to go down for every change in X. It's going to go down about 4 1/4 Y values. Okay, find the slope of this horizontal line. Well, the slope of all horizontal lines is 0. Okay? Do not ever use the phrase no slope. Just simply say the slope of the horizontal line is 0. Okay, here's some graphs of this. As you see, Y is always 4 no matter what X is. Okay, and no matter what X is in here, okay. Now, a vertical line is undefined. Do not use the phrase no slope with a vertical line. The reason for this, okay, is in that line, X is always the same. So what you would have is this minus this is always going to give you 0, and you can't have 0 in the denominator. So it's undefined slope. Now, what we'll find out in a little while is that, for example, if I had a slope of 1, +1, it would go like this. This is a slope of +1. If I had a slope of and I would go through this point 1, 2, 1, 1. If it had a slope of 2, then this line would go like this, a slope of 2. If it had a slope of 3, where X is 1, Y would be 3, and it would go like this. And if it had a slope of 10, then it would go like this. Now, what's happening? As this slope increases, the line gets steeper. What's happening is, as the slope gets bigger, you get closer and closer to infinity, infinitely steep, unmeasurably steep, which is undefinable because infinity is undefinable. Now, what if we had the slope is 1/2? Well, then it would look like this, and 1/4 would look like this, until you got down to slope of 0, which would be a horizontal line. And that's kind of the way our slope system works. Now, what they mean by this number up here is they said, no matter what the value you get up here, you're still going to get 0 as a denominator on a line where the y is missing, or in other words, a vertical line. Okay. Now, if you have different lines, this is kind of going with what I said earlier. If you notice, this is called a positive slope. Left to right, it goes upwards. Negative slope, 0 slope, and undefined slope. That's just kind of a summary of what I had already told you. Now we're going to use the slope-intercept form of a line. This is the slope-intercept form of a line. This is your friend. This is a tool you're going to use. That standard form we saw earlier is kind of like the tuxedo version, and this is the coveralls version. This is the worker. That other one's just kind of the showy. Now, what this means is the y value is going to be whatever the slope angle is, whatever the slope value is, times x, plus this b is how far up or down your y-intercept is from 0. Okay, so if we've got this equation, first thing we want to do is change this, okay, to put that, to graph that. So let's put this in y-intercept form. That means we've got to isolate this y. 3y, I'm going to add, excuse me, I'm going to move this over to the other side, which gives me 3y equals 2x minus 6. Now I'm going to divide every term by 3. So y equals 2/3 x minus 2. This is your slope-intercept form. Now, there's a very easy way to grade from that. Remember, rise over run. Now, this, the B, I told you is the y-intercept. So the way we graph with this is first we find the y-intercept, -2, right here. And we point that. That becomes our anchor point. Now, we are going to go up to right 3. Up 1, 2, right 1, 2, 3. Up 1, 2, right 1, 2, 3. Or -2 over -3x minus 2. What happens to these? They would become a positive. All that means is that I can go down 2, 1, 2, and left 2. And you can see my graph there as it's starting to line up. Now let's see their work. Okay, they've done the same thing that I did so far. They put it in slope-intercept form. They got the slope is 2/3. Again, it's just this value in front of the x. That means you're going to go up 2, up right 3. Because this is positive, you go in the up direction. Because this is positive, you go in the right direction, the greater value number direction. The y-intercept is -2, which we graphed here. You can see they just graphed it. Then we go up 2/3, and we get the second point that I got. They drew their line. It looks like I might have graphed this one wrong. What did I do wrong on that? From here down to, oh, I only went over 2 instead of 3. Okay, so let's do another problem. This one's already, whoops, this one is not in slope intercept form. So we need to get the y over here, the x over there. Okay, and they chose to leave the y over here and move the 4 over there. Now they're going to divide both sides by -2. X divided by -2, they show in -1/2 format. 4 divided by -2, -4 divided by -2 gives you +2. Okay, so I'm just going to rewrite this as y equals -1/2 x plus 2. Now, this has a negative slope. That means left to right, this graph's got to go downhill. How much downhill? Well, this -1/2 right here. Is that in my hot spot? No. This -1/2 can be written as -1/2, or it can be written as +1/2. Let me put the positive in there. Okay, all 3 of these values are the same and interchangeable. So what that means, if I've got this negative slope, I can go down 1, right 2, or up 1, left 2, because the negative side would be the smaller x values. Okay, so keeping that in mind, let's go ahead and continue this problem. They've got the slope of -1/2 I just discussed. The y-intercept in this case is +2. So we would graph the y-intercept of 2 right up here. And then we're going to go down 1, right 2, down 1, right 2. Or we're going to go up 1, left 2, up 1, left 2. Okay, write the equation in slope-intercept form. Determine the slope and the y-intercept. Graph it. Okay, so let's do that. 2x plus 4y equals 8. I need to get the x's on the other side, so 4y equals -2x plus 8. Divide every term by 4. Y equals -1/2 x plus 2. That's the same equation we had before. Okay? What is the y-intercept? Is the point 0, 2. What is the slope? The slope is going to be, which we're just going to use the letter M to represent, -1/2. What does this -1/2 mean? It means go up 1, left 2, or down 1, right 2. Okay, again, your 3 variations when you're locating points. And then we would graph it. Well, this is the same equation as last time, so I don't need to graph that. Okay, now this is a new skill. This is a new skill. In this case, we're going to have to use a formula called the point slope formula. Y minus y sub 1 equals m times x minus x sub 1. That also is a formula that you will need to memorize. Okay? Now, the way we work this, it tells us the slope, 5. The x value is -2, and y minus the y value. Okay? So we simplify this. Y minus 3 equals 5x. This becomes plus a positive. So 5 times 2 is positive 10. Now we add 3 to both sides. Y equals 5x plus 13. Okay, that is the equation of the line that goes through the point -2, -3, represented here, and has a slope of 5. What would the graph of this equation be? I'll put it over here at the far edge. The graph of this one, right here, 13, the point 0, 13, is our y-intercept, our anchor point. Then it tells us we're going to go up 5 if that's 13. So 5, 1, 2, 3, 4, 5 up and 1 over, because there is a hidden 1 under that whole number slope. Then I would go up 5 more and over 1 more. Or I could go down 5 and over 1, and down 5 and over 1. And my line would go like so if I graphed my points accurately. Okay, now let's go through their steps. Now they're going to show you an alternative way of doing this. Okay? They put in the 5 here. The x is -2, the y is 3. They substituted everything in here, and doing that, they found the value of b, 13. Okay? Now they're going to go back and substitute in. If the slope is 5 and b is 13, they're going to graph it just exactly the way that I did. Okay, and there would be your equation. Now, ultimately, you're better off on a problem like this one, just going ahead and using the point slope formula. You have a handout in your packet that gives all of the slope formulas. That handout, let me see if I can find it quickly. Okay, that handout will look like this. What I'm using right now, okay, is the point slope equation to get slope intercept equation. I need to get that out of the bright light. Okay, here's your point slope equation to get the slope intercept equation. Here is your slope formula that we had earlier. We're going to be using this today and tomorrow in both of our classes. So that's going to be kind of your main Bible for the next 2 days. Okay, now I'm not ready to go on. All right, I am ready, but I mean, I don't want to go on at this point. I want you to try some of your problems that are located in ALEKS over this slope and intercept before we go into the next part. I want to give you a chance to work on that some. So this is where we're going to stop for today. Have a good weekend. Lauren, if you're still there, I'd like to visit with you just a moment. Let me stop the recording.